Welcome to Flipped Classroom. Today we're looking at algebra and we are solving equations with pronumerals on both sides. Our learning intention is we are learning to solve equations that have pronumerals on both sides, and our success criteria is I am successful when I can add or subtract terms to both sides to solve equations and solve equations with variables on both sides. Let's look at this little bit of a puzzle. When asked how old she was, Carly replied, "In 2 years, I will be twice as old as I was 5 years ago. How old is she?" Now we can write this down as an equation. If we choose x to be Carly's current age, we can write this as an equation of x plus 2, because she first says in 2 years, and then we can write the other side of the equation, 2 outside of x minus 5, because she says she will be twice as old, that's our multiplied by 2 out the front, as I was 5 years ago, so that's the minus 5. Now we can go through and we can guess numbers for x, and if we guess the number 12, we'll be able to put that into our equation and we're able to work out that it is the same on both sides, so Carly is currently 12. Now this works for small numbers, but if we get big numbers or decimals or fractions, it might be a little bit harder to work out. So when we're solving equations with pronumerals on both sides, there's a couple of things we need to do. First, we need to move the pronumeral terms so that they're all on the one side. Now, with our questions, usually this can be done by just adding and subtracting, and we just pick one of the sets of terms on one of the sides and we do it to both sides of the equation. So for this equation here, 3x plus 4 equals 2x minus 3, we can take away that 2x from both sides and we're left with just x plus 4 on one side and the minus 3 on the other, or negative 3 left on that right hand side. Now it is good to think about this as a scale, because what we take off one side, we need to take off the other to keep balanced. And if we add something on one side, we need to add something on the other. Now we could have taken the 3x off both sides and got a slightly different equation, but it still could have worked out for us. So let's go back to that first equation that we had and see if we can solve it using this method. On the left-hand side, I'm going to do my thinking, and on my right-hand side is what I put down so that my teacher knows what I'm doing. So my first step for this would be expand the brackets. Once we expand the brackets out, it makes it a little bit easier to use. So we've expanded those brackets out. Next, we're going to subtract or add one of the terms with the pronumerals. Now we're going to use the x, so we're going to minus x off both sides. X minus x just cancels out, but 2x minus x is left with 1x, or just x, and we've still got that minus 10 on the right hand side. Next, we need to do our backtracking, and we're going to do this, and we're going to add 10 to both sides to get rid of that minus 10, and when we add 10, they cancel out, and we get 12 equals x, and because it's an equal sign, we can flip them over and get x equals 12. As always, when we're solving equations, we always want to put that value back into the equation to make sure that we've got the correct answer. So we're going to substitute that pronumeral back in, and we get 12 plus 2 equals 2 outside of 12 minus 5. We go through our steps like we did before, and we get 14 equals 14, so we know that x is one of the answers. Now, with linear equations, we're only going to get one answer. But with some questions like quadratics or quartic equations, where they're to the powers of 2 or 3, we'll have more than one answer. For our reflection today, I want you to think, why did we choose the term that we did to subtract when trying to balance the equation? And what would have happened if we chose the other term? We should still get the same answer. As always, like the video and subscribe for more videos on maths.